Determining the best plane is subjective and depends a lot on what you're looking for. Every plane excels in different areas: speed, payload, range, maneuverability, etc. Some examples of iconic and revolutionary planes include Wright Flyer, the first plane to perform sustained, controlled flight. Boeing 747, a giant of the skies, ideal for transoceanic flights. F-22 Raptor, an extremely advanced air superiority fighter. SR-71 Blackbird, a spy plane capable of reaching hypersonic speeds. The F-22 Raptor, a dominant eagle. Excellent choice. The F-22 Raptor is undoubtedly one of the most impressive aircraft ever built. What would you like to know about the F-22 Raptor? Here are some highlights to get you started. Air dominance, designed specifically for air superiority. The F-22 is virtually invincible in aerial combat. Stealth technology. Its advanced design makes it extremely difficult to detect by radar. Super cruise. It can maintain supersonic speeds without using afterburners, saving fuel and increasing its range. Maneuverability. It is exceptionally agile and can perform extreme maneuvers. The F-22 Raptor, a dominator of the skies, a fifth-generation aircraft. The F-22 Raptor is a fifth-generation fighter aircraft, meaning it incorporates advanced technologies that put it in a category above any other existing fighter aircraft. Key features: stealth. Its angular design and use of special materials make it extremely difficult to detect by radar, giving it a significant advantage in combat. Super cruise. It can maintain supersonic speeds without using afterburners, giving it greater range and efficiency. Maneuverability. It is exceptionally agile, capable of performing extreme maneuvers that allow it to outmaneuver its adversaries. Advanced avionics. It is state-of-the-art computing systems and sensors that give it technological superiority. Lethal armament. It is equipped with long and short-range air-to-air missiles, as well as an internal cannon. An expensive but indispensable project, the development and production of the F-22 was extremely costly, leading to the cancellation of series production ahead of schedule. However, the existing aircraft remain a key part of the U.S. Air Force and are considered to be among the best fighter aircraft in the world. History of the F-22 Raptor. Origins. The F-22 Raptor has its roots in the Advanced Tactical Fighter ATF program initiated by the United States Air Force in 1981. The goal was to replace the aging F-15 Eagle and F-16 Fighting Falcon with a state-of-the-art air superiority fighter. Development and production. Competition. Lockheed and Boeing engaged in fierce competition to develop the YF-22 and YF-3 prototypes, respectively. Ultimately, the YF-22 was selected as the winner. Development of the F-22 was a long and complex process, fraught with technical and budgetary challenges. Production. Serial production of the F-22 began in 2001, but due to high costs, was limited to 195 aircraft. Deployment. Entry into service. The F-22 entered active service in 2005, initially assigned to Langley Air Force Base in Virginia. Deployments. It has participated in various military operations, including Operation Inherent Resolve against the Islamic State. Notable incident. In 2023, an F-22 shot down a Chinese surveillance balloon, demonstrating its capability as an interceptor. A legacy aircraft, the F-22 Raptor is considered by many to be the best fighter jet ever built. Its combination of stealth, supercruise, maneuverability, and firepower make it an unrivaled air platform. Although its production has been halted, it will remain a crucial element of the U.S. Air Force for decades to come. The F-22 The F-22 vs. the F-35 Lightning II. Although both are fifth-generation aircraft, the F-22 and F-35 have different roles. F-22. Specialized in air superiority, it is an exceptional interceptor with unmatched air combat capabilities. F-35, it is a multi-role aircraft capable of ground attack, reconnaissance, and close air support missions in addition to air combat. In terms of speed, maneuverability, and stealth, the F-22 outperforms the F-35. However, the F-35 is more versatile and has a greater payload capacity. The F-22 versus foreign competitors. The F-22's main competitors internationally are the Russian Su-57 and the Chinese J-20. Both aircraft claim to be fifth generation, but have not yet reached the same level of development and capabilities as the F-22. Su-57, it faces development and production problems, and its true stealth capability is questioned. J-20. Although it shows progress, it remains to be seen whether it can match the F-22's capabilities in aerial combat. The legacy of the F-22. Although production of the F-22 has stopped, it remains a benchmark in the aeronautical industry. Its design and advanced technologies have influenced the development of other fighter aircraft, and its aerial dominance is undisputed. The SR-71 Blackbird, a masterpiece of aviation. The SR-71 Blackbird is an iconic aircraft, often hailed as the fastest production jet aircraft ever built. Its combination of speed, altitude, and range made it a formidable intelligence-gathering tool during the Cold War. Key features of the SR-71. Speed. The Blackbird was capable of reaching speeds in excess of Mach 3, making it virtually untouchable by most interceptor aircraft of its time. Altitude. It could operate at extremely high altitudes, placing it beyond the reach of most surface-to-air missiles. Range. With a substantial fuel capacity, the Blackbird could cover vast distances without refueling. Stealth. While not designed with the same level of stealth as modern aircraft, its speed and altitude made it difficult to detect and track. Reconnaissance equipment. The Blackbird carried a variety of sensors, including cameras, radar, and electronic intelligence systems. A unique design. The Blackbird's distinctive design was crucial to its performance. Its titanium airframe could withstand the extreme temperatures generated by high-speed flight. The aircraft's shape was optimized for aerodynamic efficiency, allowing it to achieve incredible speeds. A challenging aircraft to operate, flying the SR-71 was no easy task. The extreme speeds and altitudes placed immense physical demands on the crew. Additionally, the aircraft's systems were complex and required extensive training. The SR-71 Blackbird, a Cold War icon, the Blackbird's role in the Cold War. The SR-71 Blackbird was an indispensable asset during the Cold War. Its primary mission was to gather intelligence on the Soviet Union and its allies. Operating at altitudes and speeds far beyond the capabilities of most other aircraft, the Blackbird could penetrate deeply into hostile airspace, capturing high-resolution imagery and electronic intelligence. Key roles of the SR-71: strategic reconnaissance, gathering intelligence on Soviet military installations, missile sites, and infrastructure. Crisis management, providing real-time information during tensions and potential conflicts. Technological advantage, demonstrating American technological superiority. The Blackbird's ability to collect information over vast areas in a single flight made it a crucial tool for policymakers and military planners. Its data helped shape strategies and deter potential adversaries. Technological marvels. Beyond its speed and altitude, the SR-71 incorporated several groundbreaking technologies. Titanium airframe. The aircraft's airframe was made primarily of titanium to withstand the extreme temperatures generated during high-speed flight. Fuel management. Complex fuel management systems were essential to optimize the aircraft's performance and range. Reconnaissance payload. The Blackbird carried a variety of sensors, including cameras, radar, and electronic intelligence equipment. The Blackbird's crew, the heart of the mission. The SR-71 Blackbird was a complex machine that demanded an equally exceptional crew. The aircraft typically had two crew members. Pilot. The pilot was responsible for flying the aircraft, managing its systems, and overall mission command. Due to the extreme conditions, pilots had to undergo rigorous training to withstand the physical stresses of high-speed, high-altitude flight. Reconnaissance Systems Officer RSO. The RSO operated the aircraft's sophisticated reconnaissance systems, collecting and managing intelligence data. They were also responsible for navigation, communication, and electronic warfare. Flying the Blackbird was an incredibly demanding task, both physically and mentally. The crew members were subjected to extreme G-forces during takeoff and re-entry, and the high-altitude environment posed challenges to their physiological well-being. Despite these challenges, the Blackbird crews demonstrated extraordinary skill and courage in carrying out their missions. Challenges faced by SR-71 crews. The SR-71 Blackbird, while a marvel of engineering, presented its crew with a unique set of challenges. Physiological stress. The extreme speeds and altitudes subjected pilots to immense G-forces and oxygen deprivation. Special pressure suits were required to counteract these effects. Training rigor. Becoming an SR-71 pilot and RSO demanded exceptional skill and endurance. Training was rigorous and included specialized courses in high-altitude physiology, survival, and aircraft systems. Aircraft limitations. The Blackbird was a demanding machine. Fuel consumption was incredibly high, requiring precise planning and execution of missions. Additionally, the aircraft's skin would often reach temperatures hot enough to melt aluminum, necessitating careful maintenance. Mission risks. Operating in hostile airspace, often at low altitudes to avoid radar detection, exposed crews to potential threats from surface-to-air missiles and enemy fighters. Despite these challenges, the SR-71 crews demonstrated exceptional courage and skill, making the aircraft a symbol of American aviation prowess. The SR-71 Blackbird, a legacy of innovation. The SR-71 Blackbird's impact on aviation technology is profound and enduring. Its development pushed the boundaries of engineering and materials science, leading to advancements that continue to influence aerospace design today. Materials science. The Blackbird's titanium airframe was a pioneering achievement, demonstrating the potential of this metal for high-temperature applications. This research contributed to the development of titanium alloys for use in other aircraft and industries. Aerodynamics. The Blackbird's unique shape and design pushed the limits of aerodynamic efficiency, leading to advancements in supersonic and hypersonic flight. Reconnaissance technology. The aircraft's sophisticated sensor systems paved the way for modern intelligence, surveillance, and reconnaissance ISR capabilities. Pilot training. The extreme demands of flying the Blackbird led to advancements in pilot training and physiological research, benefiting the broader aviation community. While the SR-71 is no longer in service, its legacy lives on in the form of advanced reconnaissance aircraft, hypersonic vehicles, and the continued exploration of the frontiers of aviation. Famous SR-71 Blackbird missions. The SR-71 Blackbird was involved in countless missions during its operational life. Here are a few notable examples. Cold War overflights. The Blackbird regularly conducted overflights of the Soviet Union and its satellite states, gathering crucial intelligence on military installations, missile sites, and air defenses. These missions were instrumental in maintaining a balance of power during the Cold War. Middle East crises. The Blackbird played a vital role in monitoring tensions in the Middle East. It provided critical intelligence during the 1973 Yom Kippur War and the subsequent Israeli invasion of Lebanon. Libya incident. In 1986, an SR-71 was tasked with documenting the damage inflicted on Libyan targets after a U.S. bombing raid. The aircraft flew at extremely high speed and low altitude to evade Libyan air defenses, showcasing the Blackbird's capabilities. These are just a few examples of the many missions undertaken by the SR-71 Blackbird. The aircraft's unique capabilities and the courage of its crews made it an invaluable asset to the United States during the Cold War and beyond.
Hypersonic development, a global receding pursuit of hypersonic technology, has ignited a global competition. Several nations and companies are at the forefront of this technological frontier. Key players in hypersonic development: United States. The U.S. military has been a pioneer in hypersonic research, with programs like the Hypersonic Conventional Strike Weapon (CHSW) and the Air-Launched Rapid Response Weapon (ARRW). Companies like Lockheed Martin, Boeing, and Raytheon Technologies are also heavily involved. Russia has made significant strides in hypersonic technology with the development of the avant-garde hypersonic glide vehicle. China has demonstrated its capabilities with the Hypersonic Glide Vehicle (DFCF). Other nations, countries like India, Australia, and Japan are also investing in hypersonic research. Environmental concerns: while the potential benefits of hypersonic flight are immense, there are also environmental concerns. Hypersonic vehicles operating in the upper atmosphere could contribute to ozone depletion and climate change. Additionally, noise pollution and sonic booms could be significant issues for ground-based populations. It's essential to strike a balance between technological advancement and environmental protection as hypersonic technology matures. Beyond military and transportation, hypersonic applications, while military applications and high-speed transportation are the most prominent areas of focus for hypersonic technology, there are other potential applications that could revolutionize various industries. Hypersonic applications: space launch. Hypersonic vehicles could serve as efficient and cost-effective first stages for space launches, reducing the overall cost of accessing space. Scientific research. Hypersonic flight could enable new avenues of scientific research, such as studying the upper atmosphere and conducting experiments in extreme conditions. Disaster relief. Hypersonic vehicles could be used for rapid deployment of emergency aid and personnel to disaster-stricken areas. Communication satellites. Hypersonic vehicles could potentially be used to deploy communication satellites into orbit more quickly and efficiently. It's important to note that many of these applications are still in the conceptual stage, and significant technological challenges must be overcome before they become practical.
Challenges and opportunities in hypersonic technology. Hypersonic technology promises a new era of transportation and capabilities, but it also presents formidable challenges. Challenges: extreme temperatures. The immense heat generated during hypersonic flight requires innovative materials and cooling systems. Propulsion systems. Developing engines capable of sustaining hypersonic speeds efficiently is a complex task. Cost. The development and operation of hypersonic vehicles are extremely expensive, hindering commercial viability. Materials science. Finding materials that can withstand the extreme temperatures and stresses of hypersonic flight is a critical challenge. Aerodynamics. Designing vehicles that can efficiently and controllably fly at hypersonic speeds requires advanced aerodynamic knowledge. Environmental impact. Hypersonic flight could have significant environmental consequences, such as ozone depletion and noise pollution. Opportunities. Revolutionized transportation. Hypersonic travel could drastically reduce travel times between continents, transforming global connectivity. Military dominance. Hypersonic weapons could provide a significant strategic advantage, changing the dynamics of warfare. Space access. Hypersonic technology could lower the cost of space access, enabling more frequent and affordable space missions. Scientific discovery. Hypersonic flight could open up new avenues for scientific research, such as studying the upper atmosphere and conducting experiments in extreme conditions. Economic growth. The development of hypersonic technology could create new industries and jobs, stimulating economic growth. Overcoming the challenges and capitalizing on the opportunities will require substantial investment, international cooperation, and continued innovation. The Boeing 747, Queen of the Skies. The Boeing 747, often affectionately referred to as the Queen of the Skies, is an iconic wide-body jet airliner that revolutionized air travel. Its distinctive double-decker design and enormous size made it a symbol of commercial aviation for decades. A giant leap in aviation, introduced in the late 1960s, the 747 was a response to the growing demand for long-haul air travel. Its massive capacity allowed airlines to carry significantly more passengers than previous aircraft, making air travel more accessible and affordable. Key features passenger comfort and capacity. Upper deck. The iconic hump of the 747 houses the upper deck, which initially was used for lounges and first-class seating. Long range. With its powerful engines, the 747 could fly long distances, connecting continents and opening up new travel possibilities. Versatility. The 747 has been adapted for various roles, including passenger transport, cargo, government use, and even as a flying laboratory. A lasting legacy. While newer aircraft have surpassed the 747 in terms of efficiency and capacity, its impact on aviation is undeniable. It has transported billions of passengers, shaped the global economy, and captured the imagination of people around the world. The Boeing 747, a historical overview. The Boeing 747 was born out of a vision for the future of air travel. In the 1960s, with the burgeoning jet age, airlines were seeking aircraft that could carry more passengers over longer distances. Boeing responded with the 747, a colossal aircraft that would redefine air travel. The iconic hump was designed to accommodate a cargo loading system, but it was later repurposed for passenger lounges and first-class seating. The first 747 took to the skies in 1968, and it entered commercial service with Pan American World Airways in 1970. The aircraft quickly became a symbol of luxury and global connectivity. Variants of the 747. Over the years, Boeing produced several variants of the 747 to meet the evolving needs of the airline industry. 747-100, the original version, primarily designed for passenger transport. 747-200, an improved version with increased range and payload. 747-300 featured an extended upper deck for more passenger capacity. 747-400, the most successful variant with advanced avionics and improved fuel efficiency. 747-8, the latest version, offering increased range and fuel efficiency. While the 747-8 is still in production, the overall production of the 747 is winding down as airlines transition to newer, more fuel-efficient aircraft.
Challenges in development and operation. Technical complexity. Building an aircraft of such immense size and complexity was a daunting engineering feat. Weight and performance. Balancing the weight of the aircraft with its performance was a critical challenge. Economic risks. Developing and pilot training. Training pilots to fly such a large aircraft required significant resources and time. Despite these challenges, the 747 became a resounding success. The 747 growth. The airline industry expanded rapidly, creating jobs and stimulating economic growth. Tourism. The 747 made long-haul travel more accessible, boosting tourism and cultural exchange. Trade and commerce. The aircraft facilitated global trade by enabling the rapid transportation of goods. The become an iconic symbol of the jet age and a testament to human ingenuity. The future of large passenger aircraft. While the Boeing 747 has been a dominant force in aviation for decades, the industry is continually evolving. The future by increased fuel efficiency. Airlines are under pressure to reduce their carbon footprint. Hybrid propulsion. While still in the development stage, electric and hybrid propulsion systems could revolutionize aviation, reducing emissions and noise pollution. Autonomous flight. advances in technology may lead to more autonomous flight capabilities, improving safety and efficiency. Sustainable materials. The use of sustainable materials in aircraft construction is a growing trend aimed at reducing the environmental impact of aviation. The environmental impact of aviation is a significant contributor to greenhouse gas emissions. Addressing this issue is a top priority for the industry. Carbon offset programs. Many airlines offer carbon offset programs to mitigate their environmental impact. Sustainable fuels. Research and development of sustainable aviation fuels are ongoing, with the potential to significantly reduce emissions. Operational efficiency. Improvements in air traffic management and aircraft operations can help reduce fuel consumption and emissions. Electric and hybrid aircraft. As mentioned earlier, the transition to electric and hybrid propulsion has the potential to dramatically reduce aviation's carbon footprint.